Welcome to This Explainer. Today, we're setting the stage for a truly fascinating journey into a system that's fundamentally transforming how we interact with scientific literature. Seriously, get ready to rethink everything you know about academic research.
Okay, let's dive right into this. Just think about the status quo for a second. Right now, researchers are basically treating scientific papers as isolated islands. They're these static PDFs trapped on a hard drive or locked behind a web link somewhere. And the core problem here? Well, for every single new query, researchers and even AI models are forced to reread and completely rebuild the context of a field from scratch. It is exhausting, and quite frankly, it's really holding discovery back.
Here's our map for today's explainer. We're going to cover 1. The isolated PDF problem. 2. The Lacuna research map. 3. The build pipeline. 4. Evaluating the infrastructure. And finally, 5. The future of scientific discovery. Let's get to it.
Section 1. The isolated PDF problem, the bottleneck of modern science. Because knowledge is so siloed in these dense documents, researchers end up wasting massive amounts of time just trying to scope out their initial questions.
Which brings us to Section 2, the Lacuna research map, from islands to navigable neighborhoods. Let's look at exactly how Lacuna links the literature so you can seamlessly navigate through actual research neighborhoods.
So let's look at the sheer scale of this map, starting right at the foundation. Lacuna catalogs an absolutely massive 733,795 paper pages. I mean, that is huge. And these are all harvested and reconciled from top-tier sources you already know, like OpenReview, ARV, OpenAlex, and DBLP.
But here's the thing. Whole papers are just too big, too clunky, so the system escalates the granularity. From those papers, Lacuna extracts over 15.2 million concept elements. We're talking highly targeted 1 to 2 sentence nuggets of pure knowledge. They capture specific methods, distinct limitations, and concrete empirical findings, completely stripping away all the fluff of a standard PDF. And the scale just keeps building. Those millions of concept elements, they're then embedded and clustered together into over 27,000 distinct research directions. So we've moved from raw, scattered data points into synthesized, reoccurring problem areas and method families. It's kind of like sorting a giant puzzle.
And this whole sequence culminates in the ultimate output, 38,000 generated research proposals. These act as candidate hypotheses, they're fully grounded in the underlying map, and they are ready for a researcher to review, critique, or even take straight into the lab.
And this brilliantly illustrates exactly how those numbers actually come together. Notice how that foundational layer of over 700,000 paper pages pushes up into the granular concept elements, which then cluster into the golden layer of research directions, and finally top out at the red layer of research proposals. It proves we are no longer dealing with isolated islands here. This is a highly structured, easily queryable map of human knowledge.
Section 3. The build pipeline, demystifying the machine.
So how exactly does a raw PDF turn into a full-blown hypothesis? Well, it happens through a very clean 5-stage pipeline. Step 1 harvests and reconciles records from places like OpenReview to establish trusted author bibliographies. Then, in Step 2, Gemini LLMs step in to turn paper text and extracted figures into core idea summaries. Step 3 extracts those sentence-level concepts we just talked about. Step 4 uses an algorithm called HDBSCAN to cluster those concepts into directions. And finally, Step 5 generates the research proposals based directly on those clusters.
Now, what's really interesting about this is the stark visual contrast. A dense blue scatter plot perfectly represents the clunky, massive paper database. It's dense, it's messy, and it's incredibly hard to navigate. But contrast that with a teal scatter plot of extracted concepts. It shows how Lacuna fundamentally reorganizes knowledge from monolithic documents into a highly navigable conceptual constellation. It's a total game changer.
Let's make this abstract benefit incredibly concrete for a second. The researchers ran a test on formulating a problem around automated theorem proving. Using a sequential, raw PDF baseline, where an AI had to read the papers from scratch, took about 289 seconds and cost nearly 70 cents. But navigating through the pre-computed Lacuna Markdown pages, that took just 85.5 seconds and cost barely 17 cents. Serving existing context is just drastically faster and cheaper than rebuilding it every single time. It's a no-brainer.
Section 4. Evaluating the infrastructure, the data behind the discovery.
All right, we're setting up a heavyweight bout here between Lacuna and existing top-tier tools like OpenScholar. You really have to understand that Lacuna isn't just a search engine, it's a verifiable evidence layer. On the Lit Search benchmark for literature retrieval, Lacuna achieves a recall at 10 of 0.538, meaning it successfully retrieves the most relevant evidence in its top 10 results far more often, decisively beating OpenScholar's 0.424. And on Scholar QA CSML, which tests literature synthesis by PhD-level experts, Lacuna edges out OpenScholar again. It wins specifically on content and evidence quality, and that is entirely because of those compact citation-linked snippets we discussed earlier.
So, the crucial point is what happens when we use this map for deep multi-stage agent workflows. Enter Lacuna Deep Research. When tasked with writing full survey-style reports on the Report Bench ML benchmark, it absolutely crushes popular open-source systems like GPT Researcher and Stanford's Storm. Just consider the expert hits metric. This measures the overlap with actual human expert survey references. Storm hit 21, GPT Researcher hit 72, Lacuna hit 99. The precision and F1 scores, which measure the overall accuracy and balance of the information retrieved, are vastly superior because the map just provides a far better foundation.
To visually hammer home this victory, let's break down the actual judged quality of those generated reports, using the RACE rubric, which scores comprehensiveness, insight, and readability out of 10. GPT Researcher sits at 5.24. LangChain Open Deep Research is at 7.42. But Lacuna absolutely dominates with a score of 7.82. By running parallel workers over a pre-computed map, it produces incredibly comprehensive and highly readable survey-style reports.
Section 5. The Future of Scientific Discovery, Changing the Nature of Academia.
So let's step back from the raw data for a minute. What happens when literature actually becomes a queryable database? I want to end with this provocative thought. Can an AI-assisted peer reviewer truly evaluate scientific novelty? Right now, LLM peer reviewers struggle immensely with this. They have a massive blind spot when it comes to judging if a paper is actually genuinely new. But Lacuna's ultimate future application could fix this completely. By providing a review agent with the exact paper-grounded context of neighboring research directions and author profiles, we give the AI the actual landscape it needs to judge true novelty. Just imagine an academic world where peer review is instantly supported by the entire mapped history of human knowledge. That is the future Lacuna is building, and it's something you should absolutely be keeping an eye on.